I want to welcome you to today's session of building this complex object, a piston head. Well, I guess that's what it is called. I'm no mechanical engineer, so I'm just calling that as a piston head. I know that that's the part that goes in front of the uh, piston rod in the engine. Anyway, whatever the name is, that's not our game. Building this model is our game. So that's where I want to start. This piston head has a simple outside, but the toughest part would be these tiny little holes that goes inside the chamber. So that would be our toughest part that I can do later on. First of all, I will do the easy part. So as my boss says, grab the low hanging fruits first. And that low hanging fruit would be building this shell that I can do pretty easy with a revolve, and then I will worry about these tiny little ventilation holes later on. With that, let's start processing the image. I want to calibrate it with the longest dimension that I have on this plan, which is 86. And I want to make it half transparent for now. Also, as I mentioned, I will be doing a revolve to build this part, and that's where I want to start. So let me transform this image to match my intention. Okay. That should do. From my previous experience of handling these images, I have developed a nomenclature, or like say typical practice of handling this image, where this is a plan view on the XY plane. This to me is a front view on XZ plane, and this is to me on YZ plane. I say that on YZ plane, although it's a cylindrical object, so XZ and YZ should be the same for this case, but that's how I set my practices so far. Anything from the top goes on the XY plane, and the one right below the top view is to me on XZ plane. With that, I am going to transfer this image on a YZ plane because that's where I want to start my plan. I know it's a little quirky, but just bear with me. The YZ plane, I want to start my sketch, and I want to build half of this thing. And I'm guessing I'll have to do a lot of assumptions in here, but let me get the low hanging fruits first. This polyline is really helpful in sketching this sort of object, but I don't have to go back and forth with line and arcs. I can have them with the click of one button on the keyboard. I'm actually pressing M to change the modes on this polyline. Makes it easier. M, 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 that's what I want. And now this is tangential, that's what it's drawing. I don't want it tangential for now. Or maybe I want it tangential. So bring it there. Oh, that's a lot of steps. finally. All right, this, as you see, there is a curve here. Actually, I want to take it all the way down, and let me come back to explain that part, that little curve that I want to ignore for now. As you can see, there is a hole that goes through the object, and if you see from this side, that hole does not come, that through hole on the side, it creates the depression because there is no material in here, but actually it will be a cylinder all the way through. So I want to build it as a cylinder, and I'll worry about this hole on my second step. With that, I basically drew my sketch, and the next step is to put my constraints in there. I'll go a little bit quiet and then work on the constraints. Initially I drew the corner here with the curve it is, but the dimension here, as you can see, is given from this point to the point. For that, I decided I'd go with the straight line, and then I'll trim those corner up just a minute later. So this length is 34. Right? And this is diameter 3. This is diameter 4. I think I'll have to do some tangency here. Okay. Maybe make this vertical. Alright, the distance between these two from here to there should be 78/2. Alright, I have 4 more degrees of freedom, which is from this part. I think I'll have to do a lot of guessing. Oh, actually, I can handle one more thing. So it will be 20. So 3 more degrees of freedom that I would have to guess to make this work. Since I'm working on this plan, the guesses will be pretty close that I'm going to say. First of all, I want to make this one as 1 millimeter. Actually, that takes care of a lot of things. This one seems a little off, so 7.8. No, 8.2. That's a little bit improvement. Say 8.5. Maybe 9. I'll take 9. Yeah, I'll take 9. And I want to say the next thing would be make a tangential. So 1 more degrees of freedom, which is what is the inclination of this line. I want to say I want to fix it with this horizontal. Actually, I want to fix this same, say 5. Okay, that binds everything, and that's what we want. Let's take a look at this sketch. So it's on the right side, I'm sure. So that's our sketch. I want to revolve it with this plane, with this, which is the direction with 360 degrees. Okay, so there is my piston outside. 95% of the job done. Here we build outside shell as well as the inside shell. Now the next step is to build this hole, which I think I can do easily since I'm in the part workbench. I can do with primitive. I want to build a cylinder, and the diameter is given as 5. Hold on, let me actually make this visible. Okay, there is our cylinder. Obviously it will have to go sideways, and the diameter is given as 23. So let's make this diameter 23/2. Okay, so that's our cylinder. I want to make it sideways, so transform it. I'm going to say that should do. Yes. Now I want to make it come back sort of kind of on the left side. So position on y direction, let's bring it back by -50. Yeah, that's barely enough. The outside is 98. I made it 100, so that's barely enough. I'm good with that. On the x direction, this is 35° vertically. On the z direction, excuse me. So on the z direction, I'll have to take it up by 35, and that should be exactly where we want it to be. Now I want to make a cut. So cut this cylinder. Before that, let me rename this as sketch main. Okay, and now this is the cylinder. I want to make a cut there. So that's our cylinder. Now going back to this tip on the straight line, let's see if we can see that. Say there is our hole, and that brings us that depression sort of feeling on the straight line. All right, the next step is to build these indents on top of here. I can do that easily on this plane. So let me take this on XY plane and bring the top view here. So this is our top, that's our top. We want to make it look good, the same place. So here it comes there, just a little bit on the sideways, a tad downways. Yeah, perfect. Right, and the image is at the bottom. I can take it up, or I can make this transparent, so 75. Now I can see that image from here. Okay, it will be a little tough to see. Maybe I should bring that up. Yes, maybe I should bring this image up by 86. That's the height. So let me make that 86 and pull it up. Okay. Right. Now I want to make sketch on top of this and then do the depression. And that is going down by 4. So either there, or I can make it at 86 minus 4, that is 82. Now let me make that on top of that face. So I can make the sketch on top of this face, but following best practices, let's build a plan on XY plane and offset that by 86, right? Right where we want it to be. So this is where the technical drawing actually pays off. Okay. On here, I want to pull in this geometry, which actually, if we want to do our minimum referencing, that is 74 diameter center. I can do it without actually having that reference. So I want to draw a circle about here, and the diameter will be 76. Yes, 74 actually. So 74 over 2. That's our diameter. I want to make that construction geometry for now. And I want to draw 2 lines. I could build this one corner and then replicate it 4 times with lattice 2, but this is only a simple curve. I don't want to go to that other workbench. I can do it here. It's just 1 more minutes of work. So between these two, the length, the angle is 45, say 135, right? And this one and this one are perpendicular to each other. Okay, that makes it constrained. I want to make those a construction line too. Now the actual job of drawing these arcs. Now here is a circle. I think that's for this center. Okay, yeah. So I have to draw another circle, make that radius 30. Okay, and make it construction. Place this center of this arc on this newly drawn circle. This is given as diameter 30, which means radius 15. Yes, that worked. Okay, so we will do that 4 more times. There, that's our sketch fully constrained. I want to bring it down by 4. So I want to bring this down by 4 in the reverse direction, apply, close. And I want to make a cut. There. So we got our, let me take this back to where it was. So that's the notch that we wanted to build, and that's what we built. And that one is actually at the middle, keeping this center hole in the middle as shown in the picture. Okay, so first step and second step done. In fact, step 2.5 is also done. Now let's go work on our toughest job here, building this notch, these tiny holes. So I have to build, it says 8 times 12.5 degrees. So there is total 1, 2, 3, 4, total 9 holes. They set apart by 12.5 degrees in a radial fashion. And this doesn't go all the way around the circle. It goes little bit here and little bit there. So those are the holes here and those are the holes here. So I'll have to draw total 18 holes in 12.5 degrees apart. My plan is to build only one and then lattice them this side and then transfer them on this side. Let's do that one by one. We will do one step at a time. I want to bring back my object. I want to place this one on a Z plane, okay, and I want to take the image somewhere here. Let's make that back to 2.5. I want to make it here. Right about there. Maybe a little bit. Yes. Okay. That should do. Yep, it aligns. So here I want to draw this hole. I can probably do it if I draw this center line and then place a cylinder in that direction. And for that I want to bring back my original sketch, which was sketch main. Oh, okay, I'm sorry. That sketch is on a different plane. So that won't do any good. That sketch is not going to do any good to us. We'll have to find a workaround. Alright, draw a sketch on XZ plane. That's where this image is. That's where it is. And I want to pull in this line and this line, and there is no line. We'll have to work with that. So we got two reference lines. Now I wish I could draw this line from the reference, but I can handle that from here. It says 90 and 98, so this is 4. What I have to do is I have to draw a line here which sets apart by 4 millimeter. I want to make that a construction geometry. Okay. So the trick is to draw a line that goes through this corner, as I understand. So draw a line that goes through this corner. And this one sits 115 degree with the vertical. So between this line and this line, the angle is 115. That's what it is. Okay, I want to draw this out a little bit and maybe give it at some dimension. Say 12. Okay, 12 it is. And that's the end of this sketch. Now I want to place a cylinder, another cylinder, this cylinder align with this line, and that hole is 2 diameter, and this cylinder is 2 radius, so 1 radius, that means 2 diameter. Let me make that height as 15 for now. We will update this height as needed when I place that. Okay, now it comes to the mapping. I want to map this. Take this out. I want to place that cylinder on this line at this point. Okay. Oh. And the tangent. That worked. Okay, let's bring back the. And that's where I see our cylinder hole is. I want to see what's going on inside. So let me bring it, make it. Okay, there it is. So that's our cylinder we just placed. And this is the void that we drew with the sketching. I want to make a cut. And that will make the hole inside. So if I select this cut and then this one and make a cut, that will make the hole through that chamber, the breathing hole. Before I make the cut, actually, I want to replicate this cylinder 8 more times, 4 times on the right, 4 times on the left. To do that, I'll have to take help of lattice 2 workbench. Lattice 2, I can work with that without actually having this around. So from the top view, let's bring in lattice. I know that we have, okay, let me bring it on the XY plane. So there is this cylinder, and that's actually the piston. That's where my cylinder lies. I want to replicate that left and right. So working from top view makes more sense. Since I'll be working on top view, let me actually take this image down to where it makes more sense. There. Okay. I want to make this half transparent again, just to make sure I'm not missing anything, because I will be needing a lot of help on that. Right? Okay, now come back to polar array. See, polar array is going 360 degree. We don't need 360. We need from here to there. How can I do that? Okay, first of all, number, count. We want total 9 of them. Okay. And span end at 360 starts at 0. Now here it says 12.5 degrees apart, 8 of them. So 8 angles. So 4 above, 4 below. How about I say span starts at say 90. What changed? This changed. So now it starts at here. How about minus 90? Yeah, no. Say 45. Okay, so whatever I put here, that starts from there. I want to start from almost there. How about I say I make it a factor of 12.5. So 12.5 times 4. No, cannot put a times. So let's make a formula. 12.5 times 4. That's where it starts. And 12.5 times 4 minus. That's where it ends. Okay, we got something. It starts at 12.5 times 4, which means we are getting 1 off. I'm almost there. Okay, let me make that as 5. See if it makes change anything. Nope, wrong formula. So we make that 4. And how about I make this one as 5? Does it change anything? Yes. Oh, it worked. See, trial and error, cause this is confusing to me. So we have 9 kites located perfectly where we want them, and we have 1 cylinder. Let's replicate them with that. Oh, I know what I have. On the polar array, the radius, let's make that 0. Beautiful. So now we have 9 cylinders spaced at 12.5 degrees on right side at the angle that we built them initially, and that's what we want. Here is the cylinder that goes, the piston, so it will be piercing through that and opening up the chamber inside. We did that. Let's make a fusion, and now I'm ready to make the cut. Actually, before I make the cut, I want to mirror it on the other side. So YZ plane. Okay, I mirrored it on the other side, make that as a fusion, and now I can make the cut. Before I make the cut, let me make the transparency 0. Okay, now make a cut. Voila, we got our piston head as specified. I might be missing 1 or 2 fillets. I know that one of them is this one. So let's not worry about fillets too much. Maybe I can do that real quick here. I can make a fillet or chamfer of 1 millimeter. Yeah, that was easy. So here you go. A piston head drawn using the technical drawing, and technical drawing was used extensively to build this model, to sketch it to the way we want it. I would say having this technical drawing made this job way easier. If I had to do everything, from a different piece of paper to transfer all the measurements over there, it would be way tougher. Anyway, I hope you enjoyed this process. I know that there is another drawing for the piston rod. I'll do that next time. Until then, stay safe and thank you for watching. Bye.